So welcome back. So today we'll concentrate on the topic students frequently they are facing difficulties to identify whether the product is a substitution reaction or elimination reaction. The competition between whether the SN1 reaction or SN2 reaction or E1 and E2. So there is a dilemma will be there. So student has to be the fix the answer in a confident manner. So that in this video I would like to tell the predicting the products whether the reaction under influence of substitution or elimination reaction. So that's why, so in this one I would like to explain about the predicting the products. The products are whether the a substituted product or eliminated product. So we know that substitution and elimination reactions are very oftenly we can a competition with each other. So in order to predict the product of a reaction, it is necessary to determine which mechanism likely to follow. For example, tertiary alkyl iodide is there, and in place of a sodium methoxide, so now the E2 product, that is isobutene, is a product. Now so so it is a tertiary alkyl halide and strong base as well as sodium methoxide. So sodium methoxide is a strong base as well as a strong nucleophile, so that elimination reaction is a predominant. And this is the secondary alkyl halide. Same sodium hydroxide also can act as a strong base and strong nucleophile, so elimination reaction is the predominant and minor, so more substituted. The more shades of product is the predominant and often is the minor product, whereas the substitution also a minor. So sometimes very difficult to predict. So that's why there are the category. For example, so in here I would like to say some yeah. So you can see here. So what are that examples is that strong base and weak nucleophile. So sodium hydride, very example, sodium hydride is a very strong base, and DBU and DBN. So these and all very strong bases but weak nucleophiles. Similarly, for example, a potassium tertiary butoxide also a strong base but weak nucleophile, and for example diethyl, like that. For example, a triethyl potassium butoxide also is, it's a very, because it is a bulky group, so that it is a strong base but weak nucleophile. So what is the importance of this one here? So there is a classification is there, strong bases and weak nucleophile, and another classification is that, so here second is that strong base also a strong nucleophiles. So for example, hydroxide anion, sodium methoxide anion and sodium methoxide anion. So these and all, this hydroxide or methoxide or ethoxide can act as a strong base as well as well as a strong nucleophile. So then third category, so weak base, I minus, Br minus, L minus. So these and all weak nucleophile, but they can act as a strong nucleophile. Weak bases but strong nucleophile. So these are the examples of I minus, Br minus, Cl minus, Rs minus, Hs minus, Rh, thiol and hydrogen sulfide. So these are very good nucleophiles. And another classification, so weak nucleophile as well as weak bases. For example, neutral molecules like water, ethyl alcohol and methyl alcohol, so these are considered as the weak base as well as weak nucleophiles, right? So for example, here the table is for simplification. Here I am representing the tabular form. So primary, whether the primary alcohol or primary alkyl halide, let's say primary alkyl halide and secondary alkyl halide and tertiary alkyl halide. So now the base, for example, a strong base and weak nucleophile. So we know that what are the strong base, sodium hydride and DBN and DBU, these and all very strong base but weak nucleophile. So in such cases, elimination reaction is, because of strong base, elimination E2 reaction is the, even in the case of primary alkyl halide or secondary alkyl halide or tertiary alkyl halide, so the reaction goes through the E2 mechanism. And another one, so strong base, strong nucleophile. So what are the strong base? Hydroxide, methoxide, ethoxide, I minus, Br minus. So this and all So yeah, so strong base as well as strong nucleophile, hydroxide, methoxide and ethoxide, like that. These three anions are act as a strong bases as well as strong nucleophiles. So these, in this case, if it is a primary alkyl halide, so SN2 reaction is a predominant, E2 reaction is a minor product. And another one, if it is a secondary, E2 elimination is the major product and SN2 product is minor product. If it is a tertiary alkyl halide, and E2 is the only the product. And in a third category, so weak base but they are strong nucleophiles. So what are the weak bases? I minus, Br minus, Cl minus, Rs minus, Hs minus. So these and all weak bases but they are strong nucleophiles. In such cases, so primary alkyl halide means it is a SN2 reaction, secondary alkyl halide SN2 reaction, but it is a tertiary, means even in the presence of a weak base or strong nucleophile, the SN1 reaction is the predominate. So then another last category is that even weak base or weak nucleophile, so if it is a primary alkyl halide, no reaction, secondary alkyl halide, so no reaction, whereas the tertiary, then either it is a SN1 reaction or elimination reaction is a product. So that is very, very important, student must be remember. For example, if the substrate is a primary alkyl halide reaction with sodium, now the classification of sodium hydroxide is a strong nucleophile, also strong base, but strong nucleophile, also strong base, so that it is a primary substrate, so that elimination reaction is, so SN2 reaction is a predominant, so that the product is the butanol is a major product and 1-butene is the minor product. If the substrate is a secondary alkyl halide, for example 2-bromopropane, in presence of a strong nucleophile as well as strong base, but the elimination, so E2 product is a major, so that the substituted product is the minor product. And if it is a tertiary substrate in presence of a strong base and strong nucleophile, so only elimination product is the expected. So then the class 2, the molecule is that if it is a primary alkyl halide, but the base is very strong base, but nucleophile is very weak nucleophile. So in such cases, elimination product is a major and substitution product is the minor. So that's why 1-butene is the 80% of product, only a 10 to 20 percentage of the reaction can be expected via SN2 mechanism. And another interesting example is that, so you can see that so 2,3 dimethyl 2-bromobutane, it is a tertiary alkyl halide. So very nicely, it is a H2O is a weak nucleophile as well as weak base, but by introduction of heat and it goes the elimination reaction. Please remember that the substrate is the second tertiary alkyl halide, even neutral, for example ethyl alcohol or ethylamine or water as a nucleophile, it can act as a nucleophile and it gives the elimination product. So another so if it is a alkyl halide is a secondary, and you can see that now sodium ethoxide in presence of ethyl alcohol as a medium, so sodium ethoxide is a strong nucleophile as well as strong base. So the minor substituted product is that minor product, and the eliminated, so you can see here 1, 2, 3, 4, 2 pentene is a major product, and that also a trans product is the major product. So this is the important, student must be remember. And couple of examples you can look once again. See here, the substrate is the now chlorine is there, and it is a S configuration in presence of sodium ethoxide. So because of it is a secondary, so that there is a very less chance is there through via substitution reaction. In summary, we can expect the following. The major is that, so this is the elimination product is a major, and even the substituted product via SN2 mechanism is a minor product. So there are, so for example, so what is the name of this one? 1, 2, 3, 4, 5, 2 chloro, 2 chloro pentane reaction with sodium ethoxide, it can give the three different products. So one is the 2 pentene is a major product, and one pentene is a minor product, another one also at 10% can be expected, it is a SN2 product. So please, and another one, so yeah, practice the skill, apply the skill. Student must be the practice and also has to apply. So what is the application? You can see here some of the questions is there. Identify the major and minor products that are expected for each of the following reactions. So what is that one? For example, so now this is the 2 bromo is there in presence of a sodium chloride, even DMSO. So there is a, because it is a very weak nucleophile and very weak base, so that there is a SN2 reaction is possible, so that substitution product is expected. And yeah, so another one, for example, now the second example, you can see that this is the 2 methyl 2 pentene 2 bromo 2 pentane. Now the bromine is there, it is a tertiary substituted product. So sodium hydroxide is a strong nucleophile, so that the reaction is a tertiary alkyl halide, so that the reaction goes through the even mechanism. So the major product is that the alkene, more substituted Sergev product is the major, and minor is the Hoffman product. So you can see that another one, even though the tertiary alkyl halide, now the potassium tertiary butoxide is a strong base but weak nucleophile, so no substitution product, and only the Sergev product is more substituted product is expected. And another one, so for example, you can say 1 2 3 4 and 1 iodobutane reaction with potassium tertiary butoxide. Now potassium tertiary butoxide is a strong base, and whereas the weak nucleophile. So in this case the Hoffman product is major. So what is the product? 1 2 3 4 5. So the Hoffman means less substituted product is a major product. And another one, another nice example is that you can see that, so sodium hydroxide is the nucleophile, so that the reaction will go SN2 mechanism, because even though it is a primary alkyl halide in presence of strong nucleophile or strong base, but under thermal condition we are heating the sample, so that elimination product is the major product. So if it is a primary alkyl halide at room temperature, a dilute sodium hydroxide, in such case SN2 reaction, and the major product is that alcohol is the major product. So temperature plays an important role. And you can see here so now it is a primary alkyl halide, but the base is very strong base, and under heating condition, thermal condition, so elimination reaction is a major product. And another one, so it is a tertiary alkyl halide even in the presence of ethyl alcohol, so weak base and heating condition, so majority is that olefin is the product. So right, elimination. So student must be remember that in presence of a heating condition, the while we are applying heating, so elimination is the major product. So elimination, you can see here yeah. So even in this example, for example 1 2, so 2 cyclohexyl and 1 bromo. In this example you can see trans elimination, so by using of sodium hydroxide the product is eliminated product. You can see this is the another example. So sodium methoxide and methanol. Sodium methoxide is considered as a strong nucleophile as well as a strong base. Methyl alcohol is the medium, so solvent. So now, so because of very strong nucleophile, even the primary alkyl halide undergoes elimination product, because of it is a secondary alkyl halide. Secondary alkyl halide undergoes elimination product. So now the cyclic system, you can see that this is the cyclic system. So sodium hydroxide is a strong base, secondary alkyl halide, so that the majority is that elimination product is the major and substitution product is minor. So you can see here the mechanism how this elimination is taking place, so that 1 methyl cyclohexene is the product. So what is the product here? So elimination product. So 1 methyl cyclohexene is the product. So the bases, like for example I told, so that the bases like DBU So because of this resonance stabilization, so because of this dbu and all, very strong base and weak nucleophile, so elimination product is the major product. You can see here, for the question is that the molecular formula is C3H74 in presence of a sodium methoxide. So what is the product? So now the product is that because it is a strong base, so now the molecular formula is same but constitutional isomers. So this is the 1 chloropropane and 2 chloropropane. So you can see if it is a 1 chloro, there is a substitution reaction because it is a primary alkyl halide. If it is a secondary, in presence of a strong nucleophile or strong base, so E2 predominates, so that 1 propane is a major product. So very interesting yeah, so that's why very easily we can look at that one. Yeah, so in this one, for example, concept checkpoint solvolysis is there. For example, you can see, so which is more reactive? So because of it is the benzyl, so now even though this is a tertiary and this is a tertiary, but in presence of for the reaction of solvolysis, it is a benzyl, so that a resonance stabilization is there. So because of this resonance stabilization, this is the more reactive. And you can see, even though it is a primary alkyl halide and this is the allylic, so here resonance is there, so this is the more reactive. And this is also allylic system, and but here chlorine is there and here bromine is there. So we know that bromine is more reactive than chlorine. And you can see, so what is the question is that draw the expected products of the following solvolysis. Solvolysis is nothing but write methyl alcohol or ethylamine or cyclohexylamine. So like that. For example, you can see it is a tertiary alkyl halide and H2O and heating. So there is because in water medium it is a tertiary alkyl halide. So the major is that the elimination product. Elimination is the major product and substitution is minor product because it is a under thermal condition, under heating process. So what is mean by solvolysis? For example, now we are taking, so for example we are taking tertiary alkyl halide ethanol as a medium, so very weak base. So in such cases SN2 reaction is predominant, SN2, because no base here even in presence of water medium, so no base, so that so substitution is possible as well as elimination is also possible, but the substitution is major because no base. So no base, so ethyl alcohol, water and all, so no base, so that's why substitution is you can see here. And now substitution product, and you can see here water is there and heating condition, so alcohol is the product. And even this benzylic system now in place of, so now methyl alcohol, so it will form alcohol is there, OCH3. So we have to write this is the because, so now instead of using methyl alcohol, so methyl alcohol is the neutral nucleophile. So even you can see here chlorine is there and methyl alcohol is there, so no base, okay, very weak, so substitution reaction is possible. So once the tertiary alkyl halide in presence of a strong base, now then the elimination reaction is predominant. So what we understood, so a regiochemistry and stereochemistry aspect of this tertiary alkyl halide, so without base, very weak nucleophile, so there is a substitution reaction is possible. Please note down, these are the examples. Thank you.